like mostly go into, yeah, it's very, I mean, we have generally very interesting conversations, both technically and
Yes,
personally.
yes.
Yeah. So, hi, welcome to another session of Gen AI. So I hope this will give you some insights, and hope it will help you in your future like decision making around design. So today, so I think is everyone joined here or from Gen AI, or anybody wanted to show their faces to keep the session interactive? Yeah, thanks, Mukesh. I can see you. Yeah, it's good to see like face to face, like feel more lively, right? Okay.
I agree.
Slowly.
Yeah.
Mm.
Without any further delay, let's start. Okay, so I'm passionate towards system design. I have actually have like every time I go through system design, um, the concepts I'm understanding it, but after 1 year I'm forgetting it also. So so I don't know, like there is something that we need to, I mean, I feel that we need to go in depth of the concepts that remembers the whole life. So it is like just either by teaching others, or by repeating ourselves, right? So I have chosen the first option by teaching others. And I wanted to teach others in such a way that it that anybody can understand the basics first. Then once the basics are understood, it is easy to deep dive or understand the complex things. So that is my motto of teaching the things, because I got this idea from while I'm teaching to my kid. So the more basic, the more interestingly you teach, the more complex thing will become easy. So that's where I took this session also. Like not easy. I mean, the preparation, because storage is something like infra side, which is new to me, even though I work for Kafka team in JP Morgan. So, but my day to day is all event driven. So, sometimes I felt that I should have taken that, which is easy for me to explain, but I took the hardest one of mine, which is storage, which SREs and general SREs and infrastructure side SREs or leads will be sitting on storage designs. And I want to also know what exactly the storage is, and how the design decisions are made. Even I felt that sometimes in my existing project, I felt that it should have planned better. I mean, now we are struggling for storage for this VSIs. You should have planned better. We should have got so much memory. I mean, it's like where our few times our systems are getting crashed over because of out of memory exceptions and all. I felt that, oh, something some design decisions to be taken. Of course, 8-10 years ago, the design was maybe the designing the things with the comparatively the latest things are like enormously changed, right? Maybe 10 years back it was not there, but I felt many times the storage would have been designed so that now the current developers or the current ones who are taking up would not have went through that difficult phase of fixing again on the storage. So again, I mean, not the late, but at least learnings help us, right, to drive the future. So exactly, like now let's learn storage. I mean, it's a very important decision maker for any project to be scalable, to be durable, to be available. So there are a lot of things to be taken care of. Storage is not just disk, right? People think that storage is like Okay, putting the data on the disk. It's not about disk and keeping the data on that. So it's like lot beyond that. We have to think lot of factors. So, and how to remember those? That is a question. Like okay, we have lot of principles, rules. Like experienced experts, people made few rules and few like uh, instructions. Okay, follow this, your it will be easy for you. Yes, true. I mean, even in schools also they make some rules. And in design patterns, you take anything. If you take formulas, math formulas, why we are making math formulas? So that we will save time, to crack the problem. So some similarly, design is also like solving the problem, right? So to solve the problem, we need some rules, or we need some set of instructions, where using them, like we can solve 90% of the problem. Remaining 10% or overlays, that we can solve it with our current technology. But these principles are basis, it will be same forever. So blindly we can follow them. So I'm going. I think the introduction is, I mean, is good, or anything else before I'm going to jump. Any other questions on why we chosen this? Okay. Uh, with okay, let's. I'm sharing the screen. Let me share, and let me know if anybody unable to see, or any discrepancies. Can anyone confirm if they can see the
Your
screen?
screen is visible, Isha.
Yes.
Okay,
Yes.
great. Okay. Uh, See, I used most of the AI tools to design. Okay, frankly. Okay. Again, let's go to the basics first before we jump on the rules. What are the rules or instructions given for these designs for storage? Let's understand little bit on the storage part, right? Because when you sit on a project or in your application, like few people are talking about this, that, file system, that. So what are exactly? I mean, I won't go deeper into the basics, but I will cover what are the top level of basics, so that because we have only 1 hour, so that much I can cover for today. If any questions or deep dive, let's sit together and deep dive later. Okay. Okay. Let me go ahead. Okay, so these are the basic terminologies of storage when you hear when somebody is talking about storage and all. So just I'll go through the little bit over these things. Uh, so DAS is nothing but a direct attached storage. Take your laptop and hard drive. We can connect directly. It's only one system, one to one, like, and it's difficult to scale. So this is only for like POCs we can use for like for one system where we need the hard drive to store something. I mean, a small database where for POCs we can use. So that is something that is referred as DAS. And then okay, SAN is what you hear most of the times. It's a block storage, and it's a widely used across companies infrastructure. With it stores the raw data in the volumes, and then it's a high performant, and it's ideally used by mostly used for databases and OS volumes, and and also like VSI machines. So this is actually mostly widely used across organizations, and also sometimes when you don't want to store in a blocks, or the volume of blocks, then something in a structured way, if you want to store the data, for example, in your companies you will be seeing like you're sharing the files across the organizations for sometimes, or across your teams, right? That's required folder structure, right? So that time we will use something called NAS. It's called um, it's also a file storage, And and then similar to NAS, we have one more thing called NFS. It's not see, NAS is not something like physically network drive which is storing the data, but NFS is not the physical storage or something. It's a protocol. It's called a file protocol. It's a standard protocol used across. To it's a kind of again, we are using this internal to our teams, or sharing files and all, using this NFS protocol. Then the advanced topics are like EFS, S3, and sharding. So ESF is again by AWS, where when we want to save the file system using this NFS protocol, the AWS given a service called EFS to store the files, and which automatically scales. There is a capability from AWS, which is a managed service. Then object for object storage, we are also using S3. The advantage of S3 is it's a flat namespace and accessed via HTTP. So we can access and easy to access, because when we make it available on HTTP, it can be accessible from anywhere. So S3 is became very popular as such. And S3 is also very good for unstructured data like photos, videos, and backups. And it is something a warehouse with searchable catalog. When we have a catalog with searchable, it's easy to search here and there. But for the other, it's like very little complex to set up or to search files across, right?
Hello.
Yeah. So
Yeah, hello.
yeah. Okay. So again,
Oh,
the
yes, yes. Hi, 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 Sarita. Yeah.
Yeah. Again, sharding is one of the latest technology that
Mm-hmm.
basically, basically having this horizontal partitioning. It's splitting the data sets into smaller, and then
Okay, I'm okay with that. Yeah.
can you unmute Rakesh? Sorry, can you mute
Yeah,
Rakesh?
yeah.
Yeah.
Okay,
I just mute Rakesh.
Sorry. Yeah. This
yes, yes. I
sharding.
mentioned yourself, but as you told, like 43, I'm okay with that.
Uh,
Yeah.
Sangeeta, can you mute
Yeah.
Rakesh? Or Shravanti, you can also do it. You're also a co-host, right?
Is it okay? Let me try.
Just a second, just a second.
Mm. Yep, I did. So, yeah, this is the popular technology right now. Everybody is behind because this increases the speed, where the level of storing the data into databases using sharding techniques is like a little bit popular over because of the speed and like the technique that is using. So, this is just know the terms. That is enough to if in any conversation, if you want to talk about. But if you want to go in depth, then you can, that will be good if you go in depth. But no, knowing the terms is much more easier, because we are not
Okay.
actually using this
काहीतरी खायला किंवा हळदी घेऊन
these terms
चहा
like this.
चकली तू केली भेटताय मी
Do you have option called mute all?
Sorry. Yeah, yeah. I think, Sangeeta, you should have the
Okay. Okay, so anyway, we are just having this idea because we are not going to talk it regularly. We are just knowing the basics, but after that, it's all about the services on which were developed on top of this. Okay, so little more basics I want to cover on. So this is about cap theorem. So which is a so whenever cap theorem is not only for storage design, on other few designs also we use cap theorem, which is very important to understand. So anything, any app while developing, right? We need to understand the system, the sort of use case, what is exactly required, whether it required consistency. What matters is it consistency, availability, partition tolerance. The thing is, the base rule is these three, any of these two can be achievable. Okay, so I'll explain a little bit on consistency. So when we say the system is consistent, so so when the same data in all the nodes at the same time, see, when somebody done a read operation, and it will have the same data fetching from any time from anywhere. This is called consistency. So if you ask, if you have read some, you have asked the so sorry, any application to read some data. I mean, if you, for example, search the movie on the Netflix, right? So the user, the movie details like actor or the length of the video, everything will be same for you and me. So it should be consistent across the data, across the users. It's a simple analogy I have took. This availability is like, uh, if I request anything for the app, it should return in without any error. It should return me something. I should never feel that the system is not available. So that's called availability in shortcut. And partition tolerant is something that it, even though there is a miscommunication or communication disconnected from between any of the nodes, the any of the network, still I need to see the system is working. It should not interrupt the system, right? So that is called partition tolerance. So in partition, nothing but this the disk might be divided into some partitions. Any partition might not have communication between other partitions because the data is shared across, and similarly to the event driven, the data is shared across the partitions, and from there the communication will be happening between the nodes. So any interruption between the nodes should not affect the system. This is what partition tolerates say. So why it matters, because the CAP theorem forces to understand their application needs, right? For the use case that we take, the use case, if we got as a banking application, the banking should not double spend, or it not show the account details different. It should be consistent for across the platform. So here consistency takes the priority. And so like social medias, uh, even so the same data might not be coming. It might be different for you. The feeds are different for you, and the feeds are different for me. So it might be different, and but the only thing which is important for social media websites is availability, right? So here the bank applications might compromise on availability because the data should be consistent. So there are a lot of read and write operations too, which takes a lot of time, and the performance might be little low comparatively, and the availability of system might be little bit here and there when there are some MEPC events or some data center events. So that time there is a little compromise on availability, but the consistency is the major factor for banking or any financial applications. So that's where they compromise the applications. Whenever you got a use case, if it is mostly involved in finances, you give a priority for consistency, and availability is fine. Some around 90-95% availability is also fine. So some use case is on some social media or some social media platforms, then more to availability, but partition tolerance is common. It should be there, like the network should not be disconnected with any situation. So these two can be compromised according to the use cases. For the modern design, we got one more thing called PAC ELC. It's like some PAC is like a inverted of cap only. So, and E for else, L for latency, and C for consistency. So what it does say is, if everything work normally, then okay. Else, you have to compromise on latency or consistency, right? So like when you want to your database to respond instantly, but maybe some old data is also fine, but you have to make sure that the data should be fast. Then you should not compromise on the latency. Okay, then if your data is like wanted to have to wait for few milliseconds, and it should be perfectly synced across all nodes. It's called consistency. So then you can ignore the latency, because writing and reading the data might take some time. It's not like fast fetches. So you have to compromise on latency when you need consistency. So this is what this pack ELC extension defines. And why this is very important is, yes, for any design, these are the basics to be understand, and then implement, or you need to say to the person, okay, we can compromise here, but we should not compromise here according to our use case, right? So that decides our tech stack. Our next upcoming slides will decide based on the use case that we took. It decides on the tech stack, because these tech stacks are also developed based on the available design patterns, right? So these really matter to decide on the tech stack. Okay. So the main point is, the philosophy of the design is, it's not about like specific software we choose and integrate. It's not like that. It's about choosing the right architecture to govern our data, which lives, scales, and survives even though in failure conditions. So this is the motto of the design. Okay, let's go. Can we take the questions in the end, or you can put the questions in the chat, right? So in the end, we can answer them. Is that fine, Mukesh? Yeah, because I don't think it's already 6:30, half an hour past. We have another 30 minutes where I need to finish these uh, like few calculations also I want to show to make it interesting. So let's go ahead to the next. Uh, so I'll quickly say, I think you understood what I'm trying to say is like why we want these requirements to be ruled out before going ahead with design is, first we need to understand the problem, the use case that is given to us, because with the lack of knowledge on understanding the use case will lead us to severe losses. It can be cost, it can be resources, it can be many things. So clearly understanding problem is the first thing we need to, it's a basic rule of the requirement. And the goal is like, just we can't go and say that you use GFS for this, you use NAS for NAS file store for this. So it's not like randomly you pick and say, but you have to put few metrics on top of that to decide on the tech stack. So our goal is to not to assume the things, but to put quantifiable metrics to decide on the technical stack. So that is the goal. Okay, and so we got the use case, then we set the goal, then now we will say how to go, how to design to achieve the goal, right? So especially because I'm focused on storage, I took there are like this framework. There is some framework built around the storage. You can blindly go and use the framework to get these derivatives. And the storage design is categorized into three pillars, right? And the three pillars I'm going to explain. Let's jump on the first pillar. Okay, first pillar is about what is your data coming in, what are you storing, and because data story is always about data storing and fetching and all this stuff, right? So the first thing, what whenever use case was given to you, the first thing we have to think about is, or we need to ask the person who want us to design is, what are we storing exactly, whether it's structured, unstructured, or videos, audios, blob. So what exactly we are storing. But if anybody, you can take the notes so that in the next, when we get into use case, it will be helpful to question these things. Otherwise, it's fine. I can come back and show you the slides. So then how are you using the data? So this is also important factor that we need to ask, like what are the, I mean, data, okay, that data is stored, okay, some structured or unstructured data is stored. After that, what we are doing with the data? So how are we using the data? So this is the second pillar that we need to go through before taking a decision. And the abilities. So what is my system have capabilities to handle the data or process the data? So these are three pillars that this design, storage design, explains us, so that we will take the right decisions for the with the answers what we got, right. So let's jump on the first pillar, right. What is that? What is the type of the data that we are storing? So as I told, right, it is structured or unstructured or object or file. What is the average and max size of an item? So when we store the data, we should know, right, until what level of GB it required. Some required MB, but for some data fields it required GB. So because for smaller databases, right, like key stores, like non-SQL or SQL database are enough. But for larger ones, they should have some new SQL or some SQL level database level object store, which gives high throughput. So this max size is very important to check on, like how much max size my data can go up to. So, and what is the total expected capacity? So, the capacity management is important in any storage design, because capacity management is one of the crucial thing where leaders are thinking ahead for minimum 3 to 5 years, like how much I have to be capable of to handle the load that is coming in, or to cut the savings, to cut the costs if the users are not coming in. So this is a mandatory for the storage design. So it because and also, like, based on the capacity, we can choose the storage system. I told you, a lot of types of storage systems that we have. So that decision can be taken if we know the expected capacity. So if you see, these are all kind of a mathematical representations, mathematical questions that we are getting, right. So uh, we need answers in numbers, then only we can decide on the tech stack. So this is the pillar one that says the questions to ask. The pillar two is access patterns. Obviously, like when we store the data, we need input output operations. We are doing IOPS operations, right, on top of the data. So we need to know what exactly the system doing, what is our use case mostly tends to do, like whether it's a read heavy or write heavy. Because read heavy systems uses caching mostly, and write heavy requires sharding and durable logging for data storing the data as fast as it can. So the so we can choose the infrastructure based upon the dominant, whether read or write. So this is the first point on the access patterns of the storage design. Second one is IO pattern. So based on the IO pattern only, decide on we can decide on whether whether the IO should be sequential or eventual, and whether it should favor the high. It also have to suffer high network bandwidth. How it is going to get the network stability. So this IO pattern is also plays a mandatory, I mean, important role to match the storage and network, to decide on the storage and network to be chosen. And then latency requirement, of course, like sub milliseconds to milliseconds, sometimes minutes. So the system requires latency always, right. Because sometimes we don't require much latencies. Just if I have like less latency, I can go with in-memory caching. Means, like, I no need to have a Redis, I no need to have a very big applications for caching like CDNs and all. I can go with in-memory caching. But if I want to have high end. So then I need to like high latency, sorry, low latency and high latency. So we need to decide based upon the number of milliseconds that we are going to bear to get the data, right? So this is also one of the thing that we need to ask, what is the latency requirement, whether it's a low latency or high latency. So these are the simple questions we can put on for to get the right tech stack. So we'll again come to these questions in our use case, but just remember it. The first one, do you anyone can remember the first slide? I mean, pillar one. Pillar one is, can somebody tell me? Should I go back? What is the pillar one? It's about what? What is the data type? Pillar two, access pattern. What is the access pattern we are using? The IO operations. Let's jump on the pillar three. Uh, the pillar three is abilities. As I told, the system we need to we need to ask whether uh, do the all the users who are using systems should have the latest data immediately. It's like again, as I told, cap theorem. It also says consistency and availability. Yes, we already covered. One thing we didn't cover is durability. So durability is nothing but uh, to reduce the loss of data. So there are a lot of network packets flowing on the network traffic. So how can you ensure that the data is not lost? How can you ensure that the video uploaded is not lost? So there are like patterns like replication and erasure coding. This is, I think, nobody would have heard. I mean, I also was going through this first time. Yeah, this is the this is where we are doing the replication, like storing the same data in multiple locations, and then if something goes wrong, we are fetching from the we are failovering, or we are fetching from the different region or different data center. So it is these are all like the patterns that we have to maintain the durability. So here what are the questions we need to ask is, what is our consistency percentage, what how much it should be durable, what is the percentage of availability of system, how much cost you are expecting. So budget limit, we need to have budget also as one of the primary factor, because based on the budget only we decide on technology, whether you want to go to GFS or some normal uh, the file system and NAS or NFS. So it depends upon cost as well. So if depends upon the cost, we need to trade off between object storages or block storages or performances. So there are a lot of things involved based on the budget we have. So these are the abilities or non-functional requirements that any storage design required. So again, rewinding again, the first one is, what is our data? Second one is, how is our data? Third one is, what kind of abilities our data should have. So these are the three pillars of any storage system that we have. And then I'll quickly jump on, because we have 6:40 it is. We have 10 more minutes where I'll show you one use case. So let's go and I've choose YouTube because frankly, because Jerry was starting YouTube as a system design, and I was so much interested in knowing how YouTube stores the data. So much data in man, so enormous data. How it's managing the data. Like every day, people are uploading left and right, and how it is managing so much efficiently. And whenever I search the any video, it's quickly coming within the internet speed. So I was like wondering, I mean, I got that interest, like how it got that capability. So that's where I went into the to check on the storage of YouTube. So then I thought, okay, these are the principles that they have followed, maybe. So I mean, yeah, let's go a deep dive into how this, what is the YouTube requirement. So again, take the three pillars, right? First, what is the data? Obviously YouTube is unstructured, because it's always on not everything, like they have the data in YouTube is not only the videos that we're uploading, it also have to save user accounts, it also have to save the comments of the video, and sometimes the thumbnails of the videos, and also it also have to uh, store the count, the number of people subscribe, the subscribers. So there are a lot of data around that, how the YouTube is storing this much of data, and what are the tech stack that is using. Because see, the counts and all, the subscriber count and the comments doesn't require a heavy file system, right? Doesn't require unstructured, that is a structured data. But we have videos and all this unstructured data. How YouTube is managing these many kinds of datas, right? So for YouTube now, first is what kind of data it is getting. So YouTube is getting according to internet, the ChatGPT recently, around 1 million YouTube videos are getting uploaded per day. But but let's assume that we are getting 1 million new videos uploaded per day. See, these questions we need to ask for the person who wanted us to design, but right now we are ourselves designing. Let's assume the things. So let's assume, because when we assumed some x, if the x is changed, we can change the calculations easily. So let's drive the metrics accordingly. So assume that we have 1 million new videos uploaded per day. So this the my and it is unstructured. So the videos are unstructured and the comments are not unstructured. So our data, the pillar 1 is fixed, and the IO operations, this is YouTube is always read dominant. So because writes are less than reads. For example, out of 10,000, this is per day, right? Per day, 1 million videos are uploading, but there are 10 billion users who reads the videos. So this is read intensive, right? So we got the question, the answers for the questions that we are asking, right? For the pillar 1. Similarly for the pillar 2, so it's extensively read heavy. So million views per upload. Yes, we have million views per upload, and the IO pattern is mostly sequential reads, because reads are always sequential for streaming. Because the video I can't put half video front, half video back, right? So I have to put the video in a sequence. It should be streaming in a sequence. So it's the sequential data. That's where our second pillar is saying to decide on whether it's a sequential or eventual. So we got the second answer. And also it also talks about latency, whether it should be it's okay with low latency, or it should the throughput should be high. I mean, so the latency should be strictly maintained, because I don't want to wait for the video. As soon as I search, it should come to me, right? So it obviously the latency should be maintained. So I can't compromise on latency. I can't compromise on the reading in a sequence way. So our second pillar got answer, and then we'll go with the third pillar. What is our third pillar? Is the abilities. So for our YouTube use case, the durability should be perfect. So it should be durable, right? I don't want when I upload the video, I don't want to lose the my video. I want it to maintain. It should maintain 100%, which is not possible. So at least durability should be nearly perfect with 11 nines. So durability is always measured with 99.9999, whereas 99.99 is still with considered as less durable, but with 11 is the most accurate durability, where 100% is maintained almost. So my for my use case, yes, I need the durability, because I don't want my users to lost the data. Availability should be 99.9% plus. It means that I wanted my YouTube to be available always, because YouTube is such a famous right now. Any downtime is not entertained, or will not be good for the company. So it should be, availability should be very high. So, and the eventual consistency acceptable for content propagation delay. So the if the content is delayed little bit, that's okay. I mean, I'm because right, in cap theorem only two will be achieved, right? I'm going with availability, so I have to sacrifice consistency, right? So one should be sacrificed, because when I am expecting the high availability and durability, then I have to compromise consistency. There might be little delays in the while propagating the messages or videos. So my cap theorem got addressed here with the abilities we have. So these three pillars have been, I got the answers for three pillars. Now I'm going for estimations, right? With the estimations plus tech stack that I want to choose. So let's go ahead and see a few estimations, right? Okay, again, this is a storage requirement. I like previous video, previous slides one, I'm just giving here. We have 10 million users uploading per day with average video size. So we can't say like a few people can upload 2 GB data, 4 GB data, few upload 10 MB data, 100 MB data. So there are various uploads we are getting. Let's average it and take 500 MB, right? Because we are assuming things, the initial things to get the estimates, right? So 500 MB, and again, the uploads per day, and the durability target 11 nines, and availability SLA is 99.99. So this is our plan. This is our plan. The plan is fixed. Now we need to and we also got this thing. It's a read heavy, and eventual consistency. It's the consistency model is like strong consistency is not required. So in the cap theorem, so these are all we have. I mean, I just put another slide to explain it easily. So then let's go into next interesting part of the day, that is estimating capacity. So here I just want to use the board to explain you. We have 6:48. I'll take 5 more minutes. Show meeting board. Uh, Sangeeta, I couldn't able to see the whiteboard now.
It would.
Should
Can
I?
we? Should I? I think we should stop this first and then.
Oh, okay. Let me try that. Yeah, now I can see whiteboard. New whiteboard. Okay. Uh, so I hope everyone can see my screen now. It is
Yes.
Yes,
whiteboard.
yes, yes,
Okay.
yes, yes,
Yeah,
yes.
good. Okay, let's take the calculations here. My okay. Okay, it's 10 to the power of how many? 1, 2, 3, 4, 5, 6. Only five. Okay, I have videos uploaded as 1 lakh videos, for example. Let's say 1 lakh videos. Then what I got either is the average data that is user is uploading is 500 MB. So let's take 500. It's easy to write with pen. So now, because I need durability, and availability too, I don't want to lose my storage or my videos. I need to maintain the copies of this data. So generally, in any replication old, it must be it is mandatory to maintain 3 to 4 versions. Let's say 4 versions. Let's take the highest numbers always, so that we will be ending up with nearest values. So when you do this, like 10 to the power of 5 for 20, 20 into like three zeros will come. So it will be 2 into like it will be around 200 TB per day. So it is around 200 TB per day. Yeah. And then this is what transcoded raw data. So daily we are getting raw data of 200 dB. Then we also have to ensure that the storage, the data loss should not be there. Even though I maintain the 4 versions, but still I have this while sharding the data, I might lose few bytes of data in between due to data center failures or some other discrepancies it might. So where we are using Erasure coding, this is where like 100%, like 100% it will say that. And erasure coding is something that it actually ensures that there is no data loss, right? So but it's a little overhead on top of the storage that we are doing. So according to Erasure, it is like 1.4 of Erasure coding required for having this, not to have the data loss, which is very important for YouTube. And this comes around to 80 TB per day. Okay, I'm directly going. I mean, I don't feel convenient with the whiteboard. I'll directly explain the things. I just want to share back the I want to show actual calculations, but not easy on a whiteboard, I think. Okay, you are seeing my presentation again?
Yeah, we can.
Yeah, okay. So, like Erasure coding requires 1.4 TB. I mean, there are few calculations to confirm on this. This like I've just went through and studied about Erasure coding, like how it works, but it will take a lot of time to explain here. But you can just go ahead and see, because this is the latest technology that every company uses right now to ensure that there is no data loss. So it is coming around to 280 TB per day, and then if you take the capacity management, the data we got like per day, how much we have to store, and we should also do capacity management for next 3 years minimum, which is like coming around 307 petabytes. So it means uh, it is like read intensive. It means that we have to add some caching mechanism. Then CDN comes. I'll explain you in next slide what is CDN and all. So the CDN generally will take 2% of working set of the storage. The storage will be sitting somewhere, and the CDN will be the front warrior for the storage that was sitting around, and it won't allow hit the users directly the storage or metadata. So the CDN will cache, and if any cache miss, it again caches, and like that it will take 2% of working set. So right now it is 3.7 PB petabytes required to data store into 2%, which is coming around 6.1 petabytes. So uh, it is like 6.1 petabytes, like if like, because the caching required required some storage to store the popular videos. Like from the YouTube it was said that 95% of views have 2% of videos of, like if I have 100 out of them, 2% of like two videos will be the most popular. It means that 95% of the people watches that videos. Those will be cached into CDN, and CDNs will be sitting on edge nodes where people can easily access from anywhere. Okay, I'll explain these things little bit ahead, but we are in like 6:54. Another 5 minutes I'll be stopping. Okay. Okay. So again, I'm going to skip this slide because this is again talks about the SQL, the new SQL. So I'll cover the new SQL. So we have heard about SQL, non-SQL, new SQL. So why we have new SQL? Because we like other systems, other system designs or other patterns of system design for storage do have distributed. Everybody wants distributed now. Everybody wanted their data or apps to be distributed across the world. Especially our use case, YouTube also should be distributed because YouTube is used across the world. So the distributed SQLs are very less, and right now we have CockroachDB, and now Google came up with Spanner. So most of the YouTube chooses Google because of licensing or what, a lot of technologies they have under Google or from Google. Okay, so the new SQL is one thing that you can focus on, because other things you already know, like Cassandra, Dynamo, or all new non-SQLs which are unstructured, which doesn't require, which are not. Again, one more thing I missed is ACID properties, where SQL I think everybody know about ACID properties. If not, you can just go ahead where SQL is required for whenever we want the transactions to be perfectly going through. Like banking systems uses needed 100% accurate and consistent. So they only rely mostly on SQLs, like uh, we have SQL databases, right? MySQL, Postgres, and all. Non-SQLs, when there is a okay with consistency and accuracy of the data, then these systems will be chosen as a key value pairs if you want to save the data. So those types will be going to no SQL, but our use case require new SQL because it should be distributed. So, and one more thing is OLTP. So there is something called operational and analytical. Uh, uh, okay, this is about once again. Yeah. Okay, how you see the data changes and how to store. This is about talking about that, and OLTP is nothing but it's optimized for small and fast transactions, and for example, I told you now YouTube requires to also store subscriber count, so it doesn't require new SQL. It should not. It can no need to be distributed. So then it chooses this for subscriber count, especially it uses Spanner, which is the OLTP, um, and then video comments. So video comments are also like it no need to be distributed. So they where big table is used. So both are from Google only, but I'll just give a little more explanation on the next slide. And wherever we required analytical things, like we want to see number of like we want to do some analytics on top of some database, we use OLAPs. And right now, like out of the topic, now for the streaming reads, right, we need heavy reads, right? For that we are using blob storage. YouTube especially uses Colasys. Colasys is nothing but Google file system. It's like Google GFS is a legacy file system, but they came up with a new thing called Colasys. So I'll be explaining a little bit later. So I think this slide is mostly explain about that. Okay. So this in this why I have uh, put this slide is regarding the Erasure coding. So how it works, I want to explain it, but I will take in the next session about Erasure and all if required. And CDN is an important thing that to be remembered because CDN is the edge caching, which is mostly used in most of the applications, and this is required in every application right now. It was not there like 2 3 years. Maybe it is there, but nobody is aware of that. But now this is the important tech stack that any storage application have to include, because of this because of that uh, edge nodes, when the database is distributed across multiple regions, how we are going to cater the users. The nearest user have to talk with the nearest CDN. So CDNs are deployed in all the regions, and from there the data is cached or sent to the users. So this is very important concept that I want to cover too. Okay. So in the real world systems, like what I explained, right, for the massive capacity and sequential reads, Colasys was used, and for the strong consistency of user accounts, because user accounts should not be lost. So it should be consistent, and subscriber should counts also should be should be maintained. So for this they have I mean YouTube came up started using Spanner, and then because it's also SQL based, um, and then for high throughput and key value lookups, so it's require distributed no SQL key value pair. So comments, for user comments, it's okay if there is some discrepancy in the comments. So that's why they choose distributed no SQL key values, where again it went with the Google's implementation called Bigtable. So this is also NoSQL database that you can include. And for the latency and delivery streams, they have used CDN edge caching, and CDN is popular everywhere, and you can hear in every project right now in your organizations for edge caching and to reduce to maintain that latency. So I just gave like I didn't found much better diagram. I just plotted here and there pieces so that you'll understand where GC and CDN sits. CDN sits near the users, right? The users will directly interact with the CDNs, and CDNs talks with the data plane or Colossus where the Colossus again talks with the big table for the big table stores. I mean, this is a core database where it doesn't have access for users. So users have to when the user requests some video to see or upload, so it actually comes via API gateway where it is having services like video management or analytics service or what. There might be several services, but I'm giving you a simple example kind where the API load balancer or whatever it is having, it will talk with Colossus. Colossus is data plane again where the videos can be cached here from here. If any cache miss is again goes to the database and again fetches and put it on CDN where users can access. And for parallel processing, they have used Scanner. Even Scanner also talks with the Colossus and also sometimes metadata to store the data. So this is just like for understanding where exactly the storage systems are used by YouTube. I've just gave a picture. I so yeah, second. So I think so far you understood, right, how we are asking the questions and how we are getting the assumptions, if not assumptions, how we are getting how we need to ask the questions for the ones who want to design system, and then get the estimates. So these numbers are very very important to decide on the tech stack, and then how YouTube is choose how YouTube chooses the storage based upon the data it is having. So this I think this is what I'm trying to explain, like whenever you got a real world use case to be addressed, this is the easiest way you can crack it. Yeah. So you can get in touch with me either via LinkedIn or GitHub or Insta. And now now the floor is open for the questions. Okay, I'm going through the
Chat.
yeah.
So, shall I start?
Yeah, yes.
So, okay. So mostly you cover the file related aspect, means it basically related to the mainly with the cloud, right? AWS, S3 bucket, AWS, and Azure and GCP is also using S3 bucket, correct? And
Mm-hmm.
also CDN, right? Content delivery network, where have the global kind of edge casing. It's the again the cloud concept.
Mm. Yeah, Mukesh, go ahead.
Yeah. So
Yeah.
mainly you covered a lot of the aspect related to availability, John, horizontal scaling, vertical scaling, kind of. I believe also which is include the either have to go with the private cloud, hybrid, kind of public or private
Yes,
kind of
yes,
aspect as well as including in the
yes.
all the aspect which you covered, right?
Yeah, actually, I didn't cover the choice of clouds, I've just the choice of clouds, it doesn't matter here because it's a now we are only talking about storage. The storage can be on public cloud or private cloud. It can be it's up to the cost, if you want to get the It depends upon the which, if your private cloud is giving in less pricing, so you can better go with the storage options on the private. And if the cloud native services are giving less cost, you can go ahead with that cloud native services. It's all depends upon the cloud as well as security, because storage is also comes with security, right? So how critical your application is, like whether it can be exposed to cloud. So it depends on that as well. So which is not covered in the storage pillar, but that is also one of the important aspect to be covered according to my experience.
Okay. So manly means, I believe, means, if I am not sure, manly means this storage have to follow the best practices,
Yes.
not a design pattern, I believe. Please correct me if I am
So
wrong, if you have the.
No, no. If you want to right now, if I gave you use case, so you have to put some questions forward, right? So what kind of questions you ask? That's certainly you won't get it. But if you have some structured format, template, like these questions to be asked, then you already got the inputs. With the inputs, you can estimate things.
Yeah, but mainly it's means uh, storage have to kind of have to follow the best practices, availability. These are the
Correct.
area.
Yes, yes. You will. This session is about like getting the idea. Like whenever we have such use case, what to do firstly. Like first few seconds, instead of thinking randomly, think in a template way. Then once you got the template ready, then you can extend your thinking. Like okay, you can add these capabilities again. As you told, you mentioned the selection of the cloud or private or public, right? So that also is not mentioned in the template. So this is the out of the box. There are a lot of out of the box also to be taken. But first few days of design, you can go ahead and start with this template. Basically, it will save your time. Yeah, that's the motto.
Okay, sure. Thank you.
Okay. Amit is asking about PACELC. So it's a cap theorem. If system is running properly, it's fine. Else, latency or consistency. So again, I told you, right, the banking application versus a social media application, right? So you have to sacrifice either latency or consistency. At what scale is distributed system needed? For example, if I am building an app and it has 1,000 users per day, AWS or GCP handles all this, right? So distributed storage is needed when you wanted to keep your storage across the regions. Like nowadays, you can see the disasters happening across the regions, right? North America, sometimes like East Coast ones, East Coast, West Coast ones. Like disasters are happening regularly these days, if you see. So this is all. That's why every company is behind distributed storage, where they wanted to maintain the replicas or data backup in every region to not to have the data loss, to do failovers easily. So distributed system is needed in this era. So without distributor, till now we have maintain or manage our systems without distributed system only. That's fine. I mean, it is going fine. But what if something happens to your data center? Gone. All data will be lost. So that's where uh, it's required. Yeah.
But that's what AWS, GCP, these guys do, right? Which will try to let's say if I take a region and if I take a database, then if the it is their job to actually ensure that it's all there. Like for example, if their data center goes away, then Yeah, basically we are giving the responsibility to them. So we won't even have control, right? How do you solve that?
Those are all managed services. If your database is in AWS or GCP, then these are all managed services managed by AWS. Yeah, they'll manage the distributed only. But if it is on-prem, if it is your system, your database is on-prem, which is not distributed, which is there in NA but not in any other regions, then that time we need to take care distributed databases. Of course, yes.
Okay. So if you're using AWS GCP, then all these things are automatic.
Managed by them, and we don't have any control. But sometimes not with other every application, right? So a few applications like banking and finance, they don't want to give control to cloud, right? They wanted their databases to, because it's a very secured, it should be very secured, right? The client base and all. So that time they'll maintain the database only in on-prem. But the worry is it should be distributed, otherwise the data will be lost again. So to secure the data, nowadays people are behind the distributed databases. That's where the this cockroach DB and this next
Mhm.
Google the scanner, all these are coming into famous because of this distribute nature.
No, that if we don't want on-prem, for example, let's say I'm doing a startup and let's say if I have like, let's say 1 lakh users and if I'm using managed services, then all these concepts, will they come into picture or they're handled by the AWS or the service providers itself?
So service providers handle like I can say near to 40 to 50% because everything is managed by them. But again, you should know what your system is, right? Should not blindly go and give the control everything to cloud. So you should design like even which managed service, because there are hell lot of services on AWS. Which one you have to use? That's again a overhead on you, right? Of
Mm.
course, AWS will help us to decide on which data storage is required, right? But they also need to understand your data first. They also have to understand your access patterns first. So before them to understand, first we need to understand all these things. We need to question our data and then decide on whatever manager services are apt or for us.
Yeah, okay. No, but no, let's say if managed services are apt, um,
No, how do you ensure that the whatever cloud providers recommended or good for us? Only if we know the data, only if you know the valuable or you can say how the data is performing. So at least you should know the basics of data about. I mean, at least you should know the metadata what you are carrying, right? Then only you will choose the right service for your application. So these pillars are important not only for on-prem, it also important for cloud.
correct, correct. So yeah,
Yeah.
these concepts are required. Yeah, agree.
Yes, yes. These are very, very basic, complex, but makes a big difference.
Hmm. But let's say this cap thing, for example, let's say if you're using managed services, then is that also relevant?
Uh,
Because
because that's what I'm saying, right? The services are huge. So among them, which services are giving you that availability? Like
uh,
for storage itself, if you take AWS managed services are like around 5 to 6 services are there across the storage part. And database also, there are a lot of databases across which are managed like Postgres or MongoDB or DynamoDB.
yeah,
There
so
are
that
lot.
choice will do for sure. Like, which database to use. For example, whether it should be Redis or whether it should be Postgres. That, depends on
Similarly,
type of data and access patterns.
exactly. That's where
But once
the pillar one comes. No, I mean, what is the data, structured or unstructured? That's where you're going and deciding like which database on cloud or on-prem.
but then once that is sorted out, then it's not required, right? For example, network failures, do we really consider, right?
IO patterns. Yes, we need to, right? I mean, we need to always test our failovers. We should not rely on cloud providers. That's happened earlier. This year only, it was two times that like it got right. There are few servers went down when AWS, one of the region went down, right?
Okay.
So because few clients are unable to test their failovers.
Mm, okay.
So
Got
these
it.
are all like these are, I mean, it depends on application. If you are like your application is okay, if the downtime is like the SLAs are 99 less than 99, that's fine. If it is more, the SLAs are given as 99.99, yes, the system should be available. That time, relying on cloud providers is not advisable. We need to have failover mechanisms. That's where multi-cloud is coming across, right? Multi-cloud hybrid patterns are coming across. Your application should be deployed on not only one cloud provider, GCP or Azure, like across, so that when one AWS went down, it can fail over to other, I mean, easily. So that's where the organizations are moving ahead.
Got it. Got it.
Yeah.
Okay, great session. I mean, I
So,
understand.
so
Like if you
Sarvanti, yeah.
thanks, Shanti. Thank you.
Yeah, no worries. Yeah.
So Sarvanti, in that case also cloud provider, they are coming with the very kind of 99% nine availability as well, right? And
They
there is a
they they are,
SLA.
they are telling, but it was proved this year. Few website went on loss because of AWS and went down on one region.
So
So
there are very kind of, let's say, uh, 5 minutes kind of lost data.
yes,
They all are also coming with this solution, right? They are also mentioned in their SLA, right? That, let's say down 5 minutes, we will not able to recover before the 5 minutes. Kind of this scenario also, and it and that happen in the private cloud as well, as which I saw.
yeah. Yeah, both private and public have such
Hmm.
issues, but it's up to it's how we are like doing this failover testing and all, right? Before productionizing anything, we have to test all these failovers and performance, right? We should not rely on systems. That's what few applications couldn't able to do this manual templates didn't follow the rules, like they have suffered.
Okay,
Yeah,
thank you very much.
if plan A is not working, they should be ready with plan B, plan C. Now plan D is also.
So that's why they are replica every night.
Yes.
Yeah, they
Now,
come
now
with the.
Erasure coding. This is the new thing that I'm hearing, right? It's like very awesome, awesome. We need to go through again one more session on, especially on Erasure coding. It's a very good concept that coming up.
That's why they are coming cross region RDS. They are coming with the cross region replication as well as
Yeah.
master kind of slab as well as cloud.
Yeah. Replication was now it became old already. Yeah. Because of the cost effectiveness or cost overheads and all. Now Erasure coding is into current trend, but I don't know, might be some other thing also there which I am not aware of. Yeah.
Sure, thank
Kamlesh, you have any doubt?
Hey, thank you so much. It was really nice discussion. I got to learn a lot of things out of it, how to
Yeah.
design, at least figuring out the databases based upon the I mean the type of the flavor of the data.
Yeah.
Uh, but I have few questions. The very first is I couldn't understand in the from the pillar two is called sequential versus eventual data read.
Because-
I believe
Yeah.
you are.
Yeah.
Yes.
Actually, that's what in YouTube, right? When you start reading searching for video or like playing the video, it should be like coming in a sequence of streams. So
Mm-hmm.
I can't put the last bit into first and first bit into last. The data should flow in a sequential way. So that is sequential IO. So
Mm-hmm.
eventual IO means like some, like for example logging. So logs few logs can come first, few logs can come later. That is like eventual, event by event, whatever event comes first, that I am putting it. So for few use cases, eventual data works for few, that is fast. Eventual IO is fast because it coming this parallel batch processing already also involves. But sequential is not like that. It should come in a sequence, right? In that queue. So that will take a lot of time. So for that sequential IO, like YouTube because YouTube is read heavy, we should follow only sequential IO.
So technically, sequential is not nothing related with the media files, or it can be related with the data
Anything,
as well, right?
data
It
as
can
well,
be, yeah.
anything. Yes,
Let's
yes.
suppose say any payment system going for a OTP based. So
Mm-hmm.
technically, OTPs which are coming first should come always first.
Yep, yep, yep. Something like that.
Okay.
Yes. Actually,
Okay.
these designs are design concept which I've discussed today. These not only for storage. These are few of them also like cap theorem, acid properties. These are also applicable for different design. So eventually you'll understand once you start. Like I mean, I'm planning to take more sessions on system design so that you'll again hear all these concepts.
Okay, great to hear that. One more question. You have spoken about there is one uh, the uh, first I
A
mean slide
pillar
of that
like
DAS, NAS, something
DAS,
like that.
NAS,
So
NFS, EFS.
NFS, correct,
Yes, yeah,
sharding,
yeah,
that whole area,
yeah.
whole topic was there.
Mm-mm-mm.
So let's suppose if we are deciding, we are creating our own database in the on-prem
Mm,
based solution we are preparing, and we need
mm.
to decide which kind of a storage. So we can circulate across based upon the whatever three pillars that you have talked about. We can say that okay, this kind of a database we have to adopt. But do we have anything, any sort of a formula that you have said in the beginning, any kind of a formula to decide okay, DAS, NAS, NFS, those kind of things, does it fit anywhere, or do
So,
we?
so once you start with this deciding on tech stack, right? So underlying you don't require. So, but
Mm,
underlying, see, for example, if I want a file system, like I want to store the data as a files folder, subfolders like that. So then if I want to use file protocol to read the data, so then you have to go with NAS and NFS. But you need to directly take the concepts because these are all primitives. On top of primitives, the tech stack is implemented like
mm,
GFS or you can see there are a lot of NoSQLs like Postgres or DynamoDB. So all these things are implemented on top of that network topology.
okay,
Right. So
okay,
why I told the basics is when somebody is talking about storage, people will keep on saying NAS, EFS, S3.
okay,
People will be
okay.
saying these terms. So you should get familiar about that terminology to
Okay.
understand the depth of the
Hmm.
design. Yeah.
Okay. Okay. Yeah, that's it. Thank you
I
so much.
see you hearing and nodding, so I'm happy for that.
Yeah.
Yeah.
Yeah, thank you, it was really
Thank you.
nice
Thank you.
getting information from you, or maybe knowledge from you. Yeah.
Yeah. Thank you. Yeah, Banu Sai.
Yeah. I was hearing this term new SQL. We have traditional SQL and we are having some
Mm.
problems with SQL. That's why, in order to have eventual consistency, we adopted NoSQL. So, what is this new SQL and what are the problems? I mean, what are the pros and cons that we are getting solved? I mean, when to
Yeah.
choose that?
Yeah, so actually, most of the use cases, this SQL and NoSQL will be catered. Nowadays, what I told is about distributed. Till now, we only say for app level we have distributed apps, but never we went till now with the storage. But now storage also wanted to be distributed. I wanted my database to be presentable in across the regions. I want to be my database in US. I want to the database in Asia specific or any reason and EMEA. So anywhere I want to place my because my data is critical. For example, I don't want any data loss. I wanted like a backup. So generally, instead of putting in the same data center on the same region, we are distributing across the region so that if one region went down, the other region data will be survived. So that's the distribution is not there in earlier SQLs or no SQLs, but this is maintained with the new SQLs where Cassandra came with that. So not Cassandra. I mean, this Cockroach DB. Right now we have distributed DB. Even in our project also, we moved from Postgres to Cassandra DB. Sorry, Postgres to what is that, CockroachDB for to have the distributed SQL, right, to maintain that. So similarly, Google also have got with Scanner, because YouTube is mostly tend towards the Google technologies because of the license saving and all. They Google YouTube is mostly rely on Google tech stack. That's where if you see everywhere it uses Google tech stack.
But whenever we have a sharding or maybe replicas across multiple regions, we are compromising on latency in order to have more
Yep,
durability, right?
yep,
So,
true.
so the new SQLs will have more latency as compared to traditional SQLs.
Again, it is just backing up the data only on the different reasons, but at the end of the day, to fetch the data, again, we have to rely on CDNs, right?
Okay.
We have to rely on CDNs as well as what is your question again?
No, I was saying like a new SQL, since we are replicating, might be replicating data maybe synchronously or asynchronously. So if we are replicating synchronously, then we have to compromise on latency because we need to get consensus of multiple nodes before.
True. That is,
Yeah,
yes,
yeah.
yes. Need to compromise on this latency. Correct.
So new SQL is more of a structured or unstructured actually, because
It yeah, actually there are different distributed systems which supports both structured,
okay,
unstructured videos, blobs, block storage. So whatever applies now, that's on the storage. Everything is right now coming up with different distributed systems. This one, CockroachDB is mostly the structured one.
okay.
Yeah.
But we still, generally if we know CAP theorem, generally we have to compromise either on
One.
consistency or availability. So
Correct.
whenever there is a partition, so in new
Wow.
SQL also the same thing applies. Like if we want to
Yes.
yeah,
Yes. All the basics are same across. Only difference between the new SQL with other is just distribution. That's it.
okay,
Remaining all rest same.
okay,
Yeah.
Thank you.
Yeah. No worries. Banusai. Okay. Yes. Yeah. With that, I think hopefully I answered everyone. And I'm not in any SRE kind. Like maybe if I said any if I not correct or if I did any mistake, please excuse me. And there's lot to deep dive on storage. So it's like it's a starting. Okay, let's do more sessions and share the knowledge. And yeah, let's have more fun sessions together. Thank you. Thanks a lot for listening to me this much time.
Thank you, Shravanti. It was indeed very like the session started with very good basics, and the three pillars of storage data that you have given is very nice, right? And I think the session will give a structured approach. That's the best part of it, and that's what I think you wanted to all to have, right? Before going for a system design, we should have a structured thought, and that is something everybody will carry from here. And it covered very nice numbers. That's the most important thing.
Yeah.
Most of us are searching for those, and the case study was very well incorporated. The basics whatever you gave it very well, complemented the basics and all. And it was very nice. So what we can do is we can continue the discussion, all the participants and all the mentees. We can continue the discussion about this in our mentees group. If any of you have questions about it, you can please post there, and Shravanti can answer those
Yeah.
questions
Yeah.
there,
Yeah.
right? Thank you to all the participants
Yeah.
to be
Thanks a
here.
lot. Yeah.
Yeah, for the support. It's good.
Yeah. Thank you.
Thank you,
Thanks for
everyone.
joining. Bye bye. Have a nice
Bye bye.
weekend. And advanced Happy New Year, everyone.
Same to
Bye
you.
bye.
Bye bye.
Yeah. Yeah.